Hey guys, how's it going? In this video we're going to look at the scale diagram method for calculating a resultant vector in the context of displacement. So let's get started. Now we've got a list of bullet pointed steps here for how to do this, but I'm going to show you these steps in the context of one example. So the example we have here is that Mr. Mitchell, that's me, travels 500 meters east and then 600 meters north in his old baby blue Fiat 500 Pop. And it says old here because this was actually the very first car that I owned, and I'm not ashamed to say that I used to tear it up the motorway in this baby blue Fiat 500 Pop. So we're given some information here that we can use to calculate a resultant displacement. So it says here, find the total distance travelled and then find the resultant displacement of the car by the scale diagram method. Well, first of all, the total distance, we're told in the question that we're travelling 500 metres east and then 600 metres north. So that means I just add up my two distances, so 500 metres plus 600 metres gives me 1,100 metres, or if you wanted to write that in kilometres, you could say 1.1 kilometres. So to find the resultant displacement of the car by scale diagram, we're going to follow our steps. So let's look up here. It says first choose a scale. Now what we mean by a scale is we want to represent the distances 500 metres and 600 metres on a diagram on your page, but we can't obviously do that to scale because we can't fit 500 metres and 600 metres on an A4 page. And we want to choose a scale where it's going to give us a big enough diagram on our page to allow for a diagram to be accurately drawn. So a suitable scale to choose here would be something like 1 centimetre equals 100 metres. And that means for my 500 metre vector, I'm going to have a line that's 5 centimetres long. And similarly for my 600 meter vector, I'm going to have a 6 centimeter line. So I can draw 5 centimeters and 6 centimeter lines on a page, and that will fit quite nicely. What you then want to do is draw the first vector and make sure it's the correct length using your new scale. You want to use a ruler for this and put an arrow on the line to show the direction of travel. So remember, we use arrows on our lines to represent vectors. So here is my first vector that I've drawn with a ruler, 500 meters east, so that's my 5 centimeter line. And then the next step is to add the second vector to the first and repeat the above steps. So we want to use our ruler to draw that line and make sure it's got an arrow on it. And remember, we must add vectors nose to tail. So if I draw my second vector 600 meters north, I'm going to add that onto the tail of the first vector. So there's my nose, there's my tail, and I'm adding it on there. So that would be my 6 centimeter line that I'm drawing up there this time. The next step is to label the magnitudes of each vector and then draw the resultant vector between the start and finish point. So there's the magnitudes, 500 meters, 600 meters, and we can then draw from the starting point over here to the finishing point over here. We can draw our resultant vector, so that is this green line here with the two arrows. We then want to measure the length of the resultant vector using a ruler. So in order to get the magnitude of the resultant vector, we simply just need to take a ruler and measure the distance from the starting to the finishing point along this resultant vector. So in this case, the magnitude measured with a ruler was found to be 7.8 centimeters, which if we use our scale, is going to be the same as timesing that by 100 to get it into meters. So I get 780 meters. So that's going to be my magnitude of the resultant displacement. But remember, for a vector, we are also interested in direction. So we need to find the direction as well. So to find the direction, we firstly need to measure the angle that the resultant vector makes with the horizontal or vertical using a protractor. Now the rule that you need to remember is that the angle theta is always going to be measured next to the starting point. So if this was my starting point here when adding the two vectors together, then my angle theta must be the one in here and not the one up here in order to find the correct direction. So what we would do is use a protractor, as we said there. We would place it over here in order to find out the size of this angle. Now measuring this with a protractor, I found that the angle was 50 degrees. So I've labelled that on my diagram there. Now we're not finished finding the direction. All we've done is we've found this angle in here, but we need to put this into a direction. And we need to do this using either compass points or bearings. So it says here, work out the direction from the sketch and state this either as an angle with compass points or a bearing. We then want to state the final answer, and this should have both the magnitude and the direction. Well, I've stated the direction as a compass point and a bearing in here just to show you the two options. Well, if this is north here and this is east here, and I'm interested in my resultant vector here, then if I know that this is east and I know that this is north, then this is the same as saying 50 degrees north, round towards north from east. So it's 50 degrees north of east. Or if you wanted to use bearings instead, you can define your bearings from north, 0, 0, 0, remember. So if I go to my starting point and I have 0, 0, 0 here, then I want to just move round until I get to the resultant vector. So from 0, 0, 0 here round to here, if that is 50 degrees in there, then this must be 40 degrees in here. So I'm going from 0, 0, 0 round to 0, 40, which is going to be my bearing. So I could define my resultant displacement as 780 meters at a bearing of 0, 40. Lastly, just a point to note, if you prefer to use this method to find the resultant displacement or the resultant vector of something in general, then you need to make sure you draw the diagram as big as possible on your page. That means it's going to be more accurate when you're doing your measurements, because if you draw a little small diagram or a little small triangle on your page, it might not be as accurate as if you were drawing it much bigger. So try and choose your scale appropriately so that you're drawing a big enough diagram. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a like, subscribe to the channel, and I'll see you in the next one. Take care.